Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, I'm Nabil Azara. I want to explain about the basic nuclear final exam with the title Decaying and Reaction. So the first one is about introduction with the title Decaying and Reaction. The idea of study of particles physics is to determine the form and nature of force between the particles. This raises the question of what measurement we can do to study the forces. There are three basic properties which can be experimentally determined. The first one is the masses of energies of bound states is the mass spectrum. This is only useful in practice for the strong force as bound states of the weak interaction are too feebly bound to be seen. And the second one is the reaction rate usually expresses the cross section. As for the case, this usually only a few exchanges. Okay, and then is about decay chains. A decay is basically to change from one quantum state or the initial particle to another or the final order particles until it's observed to decay. The initial state isn't changing in any way, hence if the particle is known to exist at some time, then the probability it will decay within a short time has to be independent of how long it has lived previously. So you can see about the formula on the slide is about decay chains. In physics, a radioactive decay chain is a sequence of unstable atomic nuclei and their modes of decay, leading to a stable nucleus. Sources of these unstable nuclei are different, but engineers mostly deal with naturally occurring radioactive decay chains known as radioactive series. Radioactive series, also known as radioactive cascades, are three naturally occurring radioactive decay chains and one artificial radioactive decay chain of unstable heavy atomic nuclei. Most radioisotopes don't decay directly to a stable state. Okay everyone, so the next material is about parent isotope. A parent isotope is the original unstable radioactive isotope that undergoes decay to form a new isotope. This is the starting point in the decay chain, and the parent isotope is characterized by its radioactive properties, and the type of decay is undergoes alpha, beta, and gamma. So example is uranium is a parent isotope that starts the uranium decay series. And the next one is about Doldor isotope. A Doldor isotope is the product of the decay of a parent isotope. This new isotope can either be stable or radioactive. If it's radioactive, it will further decay to form another isotope, continuing the decay chains. So example is thorium is the Doldor isotope formed from the alpha decay of uranium. And then it's about granddaughter isotope. A granddaughter isotope is the product of the decay of a daughter isotope. Essentially, it's the second generation decay product in a decay chain. For example, is protactinium is the granddaughter isotope formed from the beta decay of thorium, which in turn was formed from uranium. And then the stable end product. The stable end product is the final non-radioactive isotope that results after a series of radioactive decays. This isotope doesn't undergo further radioactive decay and represent the end of the decay chain. For example, is lead is a stable end product of the uranium decay series. Again, next we will discuss is about half-time. Half-time is the time required to half of the atoms is example of a radioactive isotope to decay into its daughter isotope. Each radioactive isotope has a characteristic half-life which can range from fraction of a second to billions of years. For example, the half-life of uranium 238 is about 4.5 billion years. This means that after 4.5 billion years, half of the original amount of uranium 238 will have decayed into thorium 234. Okay everyone, from the next slide we will discuss is about final test basic nuclear question. And the first question is The stone that resembles ants is actually made from the nucleus of the element P2O4, which emits alpha particles with a period of 120 years to become a stable nucleus of the element O. Comparing of the P nucleus with O nucleus is 5 and 11. The mass of P nucleus 140 grams. So find the age of the Sambo amulet stone and the B when the time needs to. So in the step 1, we will make about known and ask. And known is from the question is Tp equal 120 gram and Tp over 100 and Tq equal 5 and 11, MTP equal 140 gram, and 1 AMU equal 1.67 times 10 to the power of minus 27 kilogram. X is T and B, NTP over NTQ, watts of T. And we get the answer, and the solution is MOP equal 5 plus 11 equals 16 parts, and MOP equals 16 over 5 times 140 gram equal 448 gram. So we search for MP. For MP, we use formula is MP equal MOP times half to the power of T over TP, and then MTP over MOP equal half to the power of T over TP, and then we will substitute the number to the formula 140 over 448 equal half to the power of T over 120. So we get the calculate T equal 201 year. And then for B, we will search NOP and we get the formula NOP equal 5 plus 11 equal 16 part, and then NP we get NOP times half to the power of T over TP, and then we can differential NP over NOP equal half to the power of T over TP. And then we get 11 over 16 equal 1 over 2 to the power of T over 120. And we get the calculate is the T is 65 year. And then for E, 201 year. Okay, and the next question, for the second question for final test basic nuclear is the water in the Minahasa reservoir apparently contains the element hydrogen gas and its isotopes, namely H1, H2, and H3. The water area alone has a water discharge of 4 times 10 per second and has been occurring since last year, which was collected in a holding pond. The H2 isotope has a share of 0.00241% of all isotopes, and then meanwhile, the H3 isotope has a slightly larger portion than the H2 portion. These isotopes are used as fuel in fusion-type nuclear reactors with the reaction equation B, where MH2 equal 2.01.141 U, MH3 minus 3.0161 U, and MHC4 equal 4.0024 U, and Mn equal 1.008287 and definitely find to A. The total amount of energy that can be produced by water from the reservoir. And then for B, if the electrical power consumption of North Sumatra province is plus GW and the reactor efficiency is 0.75, so when the total energy supply from the water of them will be N. So we get the known is D. We got the known as D equal 4 times 10 to the power of 6, and then H2 from the question, and direction from the question, from the question, from the question, and from the question. And then what's for the X from the question is Q total, and for B, T. How much for the T? And then from the solution, from the answer is we can put MH2 from the known from the question, and then we can search is QI, and we get 17.78 MeV. And then from the Q total, we get the formula is QI times NH2 is 70.78 MeV times 1.73 times 10 to the power of minus 30. And then we get the calculate is 49.2 times 10 to the power of 11 second. And then for the B, we can search about T, and we use the formula P equal efficiency times P out. And from the question, we get the efficiency is 0.75 times 4 times 10 to the power of 9, and then equal 3 times to the 10 to the power of 9. And we get the formula from T for 3 equal Q over P. And then we get the calculated from the result is 16.4 times 10 to the power of 2 second. Okay, for the next slide is third question, and the third question is Raphael Strike made a stick made from the jojo tree and is considered to be magical by the Maori tribe on Tex Island. While alive, this tree produced the C14 isotope from the process of photosynthesis. This proportion of the C14 isotope compared to the C12 isotope is 1.2 and 10 to the power of 11. The mass of Raphael was approximately 4.12, and when a sample was taken of 2.5 gram, the activity or decay rate was detected to be 340 kbq, determined for the A initial activity of C14 when the jojo trees were cut, and the B why and how the comparison of C14 and C12 is constant when a tree is alive, and then the C have you heard about Raphael Strike Truscott, and then the 10 is 6,400 year. Okay, from the question we get the known is from the question is MRS MRS equal 4.1 kilogram. MC we get 2.5 gram, and MC14 over MC12 equal 1.2 over 10 to the power of 11, and capital T equal 6,400 year, and AT we get 340 kbq, or equal 340 times 10 to the power of 3 BQ. Okay, from the X we get A0, and then the B MC14 over MC12 constant, and Y, and then for C, how much for the T? Okay, from the solution we get, and we use the formula is N0, N0 equal MRS over MC equal NA, and we get the calculate for A0 is 3.34 times 10 to the power of 27 per second, or equal 3.34 times 10 to the power of 27 BQ. From the B, why MC40 and over MC12 is constant, give the reason. Because if the balance between production of C14 during photosynthesis, the tree incorporate carbon dioxide from atmosphere, which is contain ratio C14 and C12. And then from the C, we get the T equal 42 year from the formula AT equal 80 times half to the power of T over S, and we get the calculate from the reason is T equal 40 year. Year. Okay, for the fourth question is there are two kinds of radius-Q nucleus methanol's that pan-Q, initial decomposing factor of that three nucleus materials, and 3 and 7. The half-time of P materials is 5 days, and after 70 days, the compression factor of 3 minerals became 7 and 3, and find the decaying half-time of Q radioactive nucleus, and the B, the comparison factor of the both radioactive nucleus materials became have the same compression factor. Okay, from the sentence, we get known as MP1 over MQ1 is equal 3 over 7, and the TP equal 5 days, and then the for 3 equal T equal 70 days, and then we get a comparison from MP2 over MQ2 equal 7 and 3. Okay, from the X we get TQ, and when T equals 120, and what MP over MQ. From the solution, we get the formula from the equation is MP2 equal over MQ2 equal MP1 times half to the power of T or TP over MQ times half to the power of T over TQ. And we get the calculate from the A, how much the TQ, we get TQ 0.8 days from the calculate result. And then for the B, for T, we get from the question t equal 120 days, and we get the comparison from the question, and we get the result calculation is t equal 1.2. Okay, for the next question, for the fifth question, and the question is, there are two kinds of the well-known nucleus models as liquid drop model and the shell model, and explain both and find the advantages and disadvantages of each model. For the B, in few of the nucleus models have spin, panty, and the Meiji number, and that term has an atomic shell. Explain this form and find the two solved problem. Okay, from the fifth question, we got there are two kind of the well-known nucleus. Is liquid drop model. Liquid drop model is a nuclear model that beats nucleus as if it were a drop of incomparable nuclear. For the shell model is a model describing the nucleus using principle of quantum mechanics, particularly the concept of quantities energy level. Okay, from the question B, for the spin, panty, and Meiji number, you can see on the slide from for minus spin over S equal half, and Meiji number and the atomic shell too. Alright everyone, thank you for watching the explanation about decaying and reaction, and thank you for your participation. Goodbye.